So here is one of the ways to get a plastic intake manifold to work that I think will work. This is a remote fuel injector mount from Alki Dragster. You can see it has a threaded bung on it. I'm thinking somewhere right here, I'm going to cut down through and point this directly at the intake valve on both sides. And it looks like I've got enough room if I trim back into here to be able to make this to work. Here's where we're at. Holes drilled. This is threaded for the bung. Got the torch set up. Ready. Honestly, it's taken a couple of PBRs to get to this point because I'm just kind of nervous about it. But there's nothing like a little liquid courage to move your projects along. Supposed to have a nice neutral flame. Say not to have a sharp cone down in there. Obviously my tip's dirty, you can hear it. You start with 5 to 10 psi on both your oxyacetylene. Junk in there, that thing. So I'm going to use flux brass rod. I've got too sharp of a cone. Try that. I don't know what I'm doing anyways, so I'm just gonna try it. So I'm gonna braze this adapter onto the cylinder head just to see what she does. You want to get your piece a little bit hot on the end here. That's what I'm doing here. Here's the finished product. Not my best work, but should seal up. Let's take a look here. Be pointing right at the valve, so there's your final takeaway of what it's going to look like. Next time you see this thing, it'll be all of the injectors in there. Here's what I'm starting with. to cut that top center section off there and see what it looks like.
Here's the initial center valley I created. This is the sketch using Fusion 360. There's the thickness and the distributor drive riser. I created the intake flanges using loft function, and you'll see here in a second that I use construction-wise to set the slope, and then a rectangle set the thickness.
Here we're looking for proof of concept again. During cutting up this intake manifold, I kind of figured out I could do this another way with probably less 3D printing. It wouldn't be as good of an intake manifold design though. Here is the cut up manifold with a general idea of what I'm looking for as a 3D printed intake. As you can see here, there's going to be some problems with my design. These bolts are incorporated into this crossover. So if I retain this crossover, this is what the general idea of my 3D printed intake manifold will look like. Now those tubes that I put in the back of the intake right here and here, I think I can put some brass fittings into here and just do some hoses through the center. And that will keep my injectors up here and these horns right here. But I think I'll retain this and then adapt my intake manifold to this using some 3D printed braces here, and then ones that go underneath the intake manifold through the valley pan to grab a hold of underneath this cylinder head. There's a lip right here. It would be perfect to put a clamp bolt right here through the center with a clamping deal. And if this is a boosted application, that would help out a lot with sealing in the intake manifold to the port.
Continuing the design, center valley is finished. Intake flange with a hole made for threading to add coolant bypass on. You can see the risers are there. I think I'll 3D print those separately, but this is a 3-piece design, and the issue is there's no coolant crossover in the front.
Moving along, trying to get this down to where it needs to be. So this is the fuel injector holder from Alki Diggers. Pretty reasonably priced and it's American made. So you can see what I'm doing here. I've got a little stand. I just notched this section here. This engine has to be gone through, so I'm leaving it fully assembled. And all those shavings are going to come out of it when I go through it. It has a spun bearing on number 6. You can see, it kind of sits in there like that. And to reduce 3D printing, I've shaved this down. Again, this is just for a proof of concept. You can you can 3D print the entire thing, but I'm just trying to get one that looks like it'll work using what I have.